Yeah, thanks. Welcome to my presentation. As you said, my name is Dawin. I'm a researcher based in Munich, and I will be talking about Kakao Talk, which is South Korea's biggest mobile chat app, and how I found a way to steal another person's messages by just clicking a link. Yeah, the structure of the presentation will be as follows. In the first part, I will just talk about what Kakao Talk is all about, how it works, how the protocol works, what are the basic flaws in the protocol. Main part of the presentation will be the vulnerability that I found in the messaging app. And in the last part, I will just conclude. All right, so what's the Kakao? So as I said, Kakao Talk is the biggest chat app in South Korea. It's basically the WhatsApp of South Korea. It has more than 100 million downloads from the Google Play Store. And nearly 43 million daily users in Korea alone. And it's a so-called super app. Whoever of you know maybe WeChat, like it's an app with all the features included, like ride-hailing, payment services, shopping features, etc. Not only chat. So attack services are huge. I'm talking about Kakao Talk. They offer different chat rooms. There's regular chat, team chat, secret chat, and open chat. So basically different chat rooms for different usages. And I took a look at the regular chat feature of the Android version 10.4.3 last year in December, and just took a look at it. So under the hood, there's a proprietary protocol called Loco. So it's not the Berlin chicken brand or the Spanish word which means crazy. It's presumably just like an internal project name made up by Kakao Corp. And it's a really straightforward basic protocol based on TCP. And they just use binary JSON under the hood. So it's just JSON in the binary format, as the name suggests. And what they do, they simply encrypt the traffic with an AES key that is shared with the company. And talking about the architecture, it's also a very straightforward messaging architecture, store and forward. So that means there's a server in between. And if, for example, one participant is offline, the server would cache your messages. And if you get back online again, then the server would forward the messages to the recipient. And already back in 2012, there was a researcher called Brian Puck, and he reverse engineered most parts of the protocol already, so 12 years ago. And since then, the core principles of the protocol haven't changed. They just added some other features on top, but since then, there hasn't been any much changes. And that's an example of one of the packet payloads. You can see in line number 8 that they use like a so-called command or local command, which is tied to each action. And in this example, the swrite command means that you are sending a end-to-end encrypted message with the Kakao Talk app. And then if you look at line number 2, like that's just like the payload. And like in the middle of the screen, the M option, that's just the message which is first encrypted and then base64 encoded. And then there's some header fields involved. So structure is pretty basic. And since it's like a simple protocol, there are also like some, I would say, vulnerabilities as well. So first of all, there's no server authentication whatsoever. So from HTTPS, you would say, that there's a server that presents a certificate to prove its identity. But there, for the local messaging backend, there's no such a thing. So if you would present a rogue server, that wouldn't be detected by the client. I told you that there is AES encryption on the ciphertext, but there's no integrity protection. So you could potentially flip bits on the ciphertext. And since they use a malleable ciphertext, block cipher suite, a block cipher mode, in this case, cipher feedback mode, targeted bit flipping attacks might be possible if you know parts of the plaintext. And if some of you remember maybe the Chaos Communication Congress from 2018, there was a nice presentation on hacking PGP email clients, and this was like called the e-fail attack. And this was exactly what they exploited back then, just by knowing some plain text, and there wasn't any integrity protection on the ciphertext. You can basically inject your own code into the ciphertext. I also put like a proof of concept on my GitHub if you want to play around with the traffic. to just reproduce this thing. And yeah, there's also no replay attack prevention. So I was, as I said, just digging at the protocol with man-in-the-middle proxy, and you could just happily repeat the messages. The client the client would just accept the messages and wouldn't throw them away. So there's no nonce or freshness values or anything like that. Yeah, coming to the main part after introducing Kakao Talk. Yeah, like a quick recap of the regular chat feature. So that's the main thing used by all Koreans. It's just like as for any other chat app, you have one-on-one chat, group chat functionalities. And yeah, it's really popular in South Korea. Even government officials, journalists, like everyone in Korea uses Kakao Talk for messaging. Yeah, it uses the local protocol under the hood. Yeah, and there is no end-to-end encryption by default. So unlike in WhatsApp or Signal, you have end-to-end encrypted messaging by default. Here it's not enabled. You just have this basic AES encryption. So potentially the company could read your traffic or read your messages. Right. So I told you that Kakao Talk is like a monster app or all-in app. It has many features, and it also has a shopping feature. And this was actually the entry point that I found for my exploit chain. So they have a web view called Commerce Spy Activity, and on Android, a web view is just like another way of displaying websites in your app. And the first thing, as a researcher, you dig for the low-hanging fruits, right? And the first thing you usually look at is deep link parsing issues, and that's what's the case here. So Commerce Spy Activity, they just rendered this this URL here, buy.kakao.com. And you can start that with a deep link. And on deep links are a way on Android to start app components. So if you click this link here, Kakao Talk //buy on your phone, then this web view on the right-hand side would pop up on your phone. And also cool from an attack point of view, it has JavaScript enabled. And then it also supports the intent scheme. So that's another URL scheme for starting app components via JavaScript. So if you would click like an intent URL on this side, that could start like any app component within Kakao Talk. And the cool thing is also from an attacker's point of view, you could start non-exported app components. So if you, like some of you might know Android development, if you have like the Android manifest and you can set like app components to exported or non-exported. With the intent scheme, you can even start non-exported app components. Yeah, but the best part was that this web view leaked an access token in the HTTP request header. And so my goal was, okay, can I somehow steal this token from the user and play with it? So I digged at the deep link parsing or deep link validation. So on the top, you see that they just hard-coded this URL, buy.kakao.com. And yeah, this just gets rendered in the web view. And at the bottom of the page, what they actually did correctly is to validate the scheme, so Kakao Talk, and the host component of the deep link, which is the string buy. So that's what they did correctly, and you should always do that as well. But then, as you can see in this screenshot, they just used the format method of the string class to concatenate this string with like the path component of the URL, query parameters, or the fragment of the URL. And that's what I, as an attacker, could control. To give you an example, at the bottom, you can see, so for example, what was possible, if you click this deep link, Kakao Talk //buy/foo, since foo is like the path component, you can this would get injected and just append it to the URL buy.kakao.com/foo, and this would be rendered then in the web view. So yeah, I thought, okay, cool. So those three parts I can control as an attacker. Okay, now how could I possibly run my own arbitrary JavaScript in the web view? So I like dig deeper. So for example, the straightforward thing would be that you, just include some JavaScript in the deep link URL and would try to run this in the web view. Okay, this didn't work. Also, there was no XSS on buy.kakao.com. And also, I couldn't just man in the middle of the traffic because there was HTTP involved. And of course, you could tamper with the phone and change some certificates on the phone, but for that you need physical access to the victim's phone. But I was lucky. I found on this domain buy.kakao.com, I found this redirect endpoint, a clean front-end redirect, blah, blah, blah. And this would redirect to any kakao.com domain. And that was pretty cool because this allowed me to find like this basically increased the scope of my XSS because I could like just browse any of those subdomains for possible XSS flaws. And that's what I did. I continued digging. So basically this was also pretty much straightforward. I was browsing all kakao.com subdomains, and just by using a Google dork, you just Google for it. And you know that search fields are a prominent vector for XSS flaws. So I just included the search in the Google query. And yeah, then I came up with a bunch of websites, and yeah, I was lucky. I found this shoppinghow.kakao.com that had a XSS in the search. And I found this with Burp Suite's DOM Invader tool. So that's like a feature of Burp Suite to find XSS flaws in the DOM. And this was the case here. Also, payload in the fourth bullet point, just a simple XSS payload, nothing crazy fancy. And yeah, by this I was able to run my own arbitrary JavaScript in this particular web view, and yeah, I was able to steal the user's token. Right, final payload, just a concatenation of stuff. Yeah, you see at line number 7, that's the deep link, right? kakao.doc/buy. Then line number 8 is the redirect that I used for redirecting to another subdomain. Line number 9 is the vulnerable XSS site. And line number 10 is the XSS payload. And then you just like concatenate all this stuff together and you get this long link that the user has to click. Right, yeah, another breakdown. So that's the deep link that would fire up the vulnerable commerce buy web view. Yeah, the redirect, and yeah, the shopping website which had the flaw. Yeah, the XSS payload. This would just redirect the web view to my web server, to my own server. So with a document location, you can change the location of the web view basically. And I just had to base64 encode my server URL because there were some WAF checks on the server side going on. Yeah, and with that deep link, yeah, I could grab the access token from the user. So I got this token. So, but what could I potentially do with it? Yeah, the neat thing was that I could access another user's Kakao mail account with this access token. And also another great thing was that I could create a new Kakao mail account on the user's behalf with this token. And this would happily overwrite the previous registered email address with no additional checks. So of course this was cool, because then I could just like create a new email address on the user's behalf. I could access the email, and then what do? You just reset the user's password. And yeah, then that's just really simple account takeover. Yeah, there were some client checks going on through the password reset procedures, but they could also easily bypassed with Burp because everything was just implemented on the client side. Right, for the proof of concept, I just pre-recorded a video because Kakao Corp, they fixed the issues. So what I did for the proof of concept, I'm just starting a HTTP server that would serve the deep link, then another window, a netcat listener that would grab the access token from the user. Yeah, then I would use this access token to take over another person's account. And then me as an attacker, I would try to register like my attacker's device to the user's account. So, and by that, the messages are synced. So you know this probably from if you use like WhatsApp Web or the Signal desktop app, that the messages are synced between your phone and the desktop version, and that's what's the case here. They have like a Kakao Talk desktop client, and that syncs your messages to your device. And even though there was like a second factor involved, so they require you to enter like a 4-digit PIN, and I couldn't brute force that because there was some rate limiting going on the backend side. But however, I was in possession of the access token, and with the right curl command, you can just ask the backend, and I would happily tell you the PIN, which you can see like on the bottom of the page. I got the PIN and basically could register my own phone to the victim's account. Okay, demo or GTFO. Okay. All right, so what you can see here on the video on the left-hand side is the victim. Center top is the HTTP server that serves the deep link. Center bottom is the netcat listener for grabbing the token. Right-hand side is the attacker's device, basically. Yeah. I'm just chatting with the victim. White is the victim, yellow is the attacker. Okay, I'm stealing your messages. All right. Okay, I'm sending the server URL that serves the deep link. You're gonna see the GET request. Okay, now the commerce by web view opens, or the JavaScript gets executed, and it leaks the access token here. I can grab it with netcat. And then in the background, I can reset the user's password with that access token. Right. Okay. And yeah, you got the credentials, and I just log in. Messages are being synced, and I can access the victim's, that's the victim's account. And you see the same chat, and now I'm just responding as the victim, basically. Yeah. Okay. Right. All right, coming to a conclusion. Responsible disclosure. So I reported this last year in December via Kakao's bug bounty program. And the fun thing was that this only entitled to Korean citizens. So I didn't receive anything, which is fine, but it was a bit awkward. The vulnerable web view was removed in later versions. The redirect was removed, and they also fixed the XSS. Long time ago, 2016, I already took a look at the Kakao Talk, and I found some protocol issues, and I reported them back then, but they were never fixed. I contacted them again now in July, but I'm still waiting for a reply. And if you want to read all the correspondence, I put like the correspondence with Kakao on my GitHub if you want to read that. Yeah, lessons learned for me at least. I think which was fascinating, that there are still like really, really popular chat apps which don't need a crazy exploit chain to steal another person's messages. If you think about WhatsApp or iMessage, where you need like a crazy exploit chain to take over another person's account, here this was like just a simple deep link parsing issue in the end, with some combined issues on the backend side. And also, if you think about maybe that app developers, they might think, okay, Android is a secure platform. I don't need to worry about so much about code security. As you have seen, if you just introduce a simple logic bug in your code, this could screw your entire security, even though having Android features like app sandboxing and stuff like that. And also, like, as far as I know, those mega apps, they're still underrepresented in the research community. And I hope, guys, this will encourage you to dig into this, because there's plenty of attack surface. And and that's it. All my proof of concept code is online on GitHub. There's also a full write-up of this presentation if you want to read the details. And if you want to reach out, you can reach out here at the conference or on Mastodon or still X. But now I'm happy to take your questions. Thanks.
Who would like to have first question? Please go ahead.
You mentioned that there were some other things that you found with Kakao Talk. Can you say a little more about those, or should you not, since you've reported them and they're in process?
Yeah, there's also like an end-to-end encryption feature in Kakao Talk called Secret Chat. It's like a dedicated chat room just for end-to-end encrypted messages. And it's also based on this local protocol. So this end-to-end encryption protocol was just like put on top of the old legacy stuff. So it suffers all the vulnerabilities as no ciphertext integrity protection, no server authentication, no replay protection. And so it just suffers all the best practices that you would see from an end-to-end encryption protocol. And that's another thing I found. I also put this on my blog, like a dedicated blog post, if you want to read this. Yeah.
You mentioned that it's using AES protocol, so it means that even the client key is stored on laptop locally, this AES key, so that attacker can potentially use it?
No, the AES key is basically if you install the app, it's stored locally on your phone, like in RAM or something, and on the server side. So if you have malware on the phone, of course you can dump the memory. But it's like still sandboxed because like other apps cannot easily access the AES key. It's like, because it's still like sandbox. But if you like have a rooted phone, for example, or malware in your phone, then you can get the key. Yeah.
Thanks for your talk. I was thinking about a shortcut when they concatenate the Kakao.com and the query part.
Mm-hmm.
Couldn't you just pass a dot in your own domain in the query part so that Kakao.com would be interpreted as a subdomain of your domain and just skip the whole XSS part? Or would the authorization header just be transmitted to the Kakao.com domain?
Exactly. I tried that as well. But they just they validate the buy.kakao.com domain in the header.
Okay.
Yeah. Yeah.
More questions, please.
Why was the authorization header sent to your listener? Was it?
Yeah, in the XSS, I basically put this document location, so basically changing the site in the web view. And if you do that, they send this HTTP request to your server. Like I put my URL in there, and they leak the access token in the request header. So
Okay,
that's how you can grab it.
So it was already available in the JavaScript of the Kakao Talk website.
Yes.
Okay.
Yeah.
Thanks for the talk. Just have just random question. If you would have used Burp Collaborator to get the access token, that would have worked, or you need a listener?
I haven't. I think potentially this would also work. Yeah. If you use just the collaborator.
Yeah. And where did you host the Netcat listener? Just AWS instance would suffice?
For the POC just locally on my. Yeah, but I think for a real world attack, you just host it anywhere. AWS, for example. Yeah.
All right. Thanks.
Thanks for the talk. My question is more general about the local protocol. So how do you approach the research on the protocol itself? I think it is maybe closed source or it is open source. Mm-hmm. But if it's closed source, how you started studying it, so via like reverse engineering it, collecting data, or just you had some more knowledge about this?
Just I had a rooted phone, and I just hooked the function calls with the Frida, and by that you can just like dump the contents, and then I'm just dumping the packets and poking with it with man-in-the-middle proxy. So you just like hook the function calls first with Frida to basically disable the encryption in order to see the plain text traffic. And then you just man-in-the-middle with man-in-the-middle proxy. Yeah, but also back in 2012, like there was also some research already. So some guy, Brian Puck, he already reversed many parts of the protocol. So, and since then it hasn't changed much. This also helped, of course. Yeah. But since it's just based on TCP, it's pretty straightforward.
Hi, I was just checking out their website and noticed that they have a finance assets thing. Is this also affected? If you're aware of the feature.
No, I'm not aware of the feature. They have like a corporate or business chat feature. It's called.
They call it wallet.
They have everything. I don't know. Like they have. I think it's really prominent for paying. Like if you go to Korea, that you pay with Kakao Talk. I haven't taken a look at the payment feature, but just at the chat functionality. But if there's a wallet, probably there are maybe some bugs.
All right, thanks.
Yeah, thank you for the presentation. I have a question regarding the pin proof function. You have said this is no proof possible, no? And at the end, you can find the ping on the server. So maybe you can explain more about this. So because this looks like the result in both tool. That's this verified tool, and then you see the ping. So this is locked, or so maybe tell more about it.
Yeah, as I said, I use a bunch of tools for just poking at the web traffic. It's Burp, of course. It's straightforward. Then for finding the DOM accesses, I used the DOM invader feature, and then for poking at the protocols, the proprietary protocol, just man-in-the-middle proxy, man-in-the-middle dump, Frida, and that's it. So not many netcat.
One last short question, maybe.
Hi, thanks for the talk. Which phone did you use for? You said you rooted an Android, right?
Yeah.
Can you recommend like an Android phone for?
There's one of the sponsors here.
Okay.
They have phones that you can root, or that they provide root. Yeah.
And have you used a physical phone or?
No, like in my case, just an emulator.
Okay.
And the emulator is easy to root as well.
Okay.
Yeah.
Does it come rooted, or you just have to change the setting?
Yeah, you need to put the system partition to read-write when you start the emulator, and then you can change certificates on the root partition. So, but it's straightforward. You don't need a root exploit for the emulator.
Okay. Thank you again, Dawin, for your great presentation.
All right. Thank you.